Hello everybody and welcome back to some more practice with math and geometry with Mr. H. I hope that all of you are doing well and enjoying the snow or what's left of it outside. To begin today's class period, what we want to do is determine if each pair of triangles is similar. If they are, I want you to use which set of similarity conditions you are using. So right now, remember we have side, angle, side, 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 and angle, angle as our three choices to be able to determine whether or not two pairs of triangles are similar. So I'm going to let you try and practice this independently right now, so you can pause the video, write down your work, and then we will talk about them. So hopefully we've had a moment to work through these problems. The first problem is similar by side, side, side. As you note, I took a look at the scale factor for each of the corresponding sides, and I found that zoom factor or enlargement factor was 2 between each of the corresponding sides. So I have 3 pairs of sides for that. So by side, side, side similarity, those two triangles are similar. This one, anytime that you have overlapping triangles, I would encourage you to draw them separately like I did here. So this big triangle in blue, you should notice that that has the same angle up top as this one here. And then if you recall, this little arrow here with this little arrow means that those two sides are parallel to one another. And if we have two parallel lines cut by a transversal right here, we're going to see this a lot with these pairs of overlapping triangles. This angle and this angle are going to be the same measure because they are corresponding angles. They're in the same relative position at the intersection points. So I can say that this angle and this angle up here are both equal to each other by corresponding angles of parallel lines cut by a transversal. There's also this angle and this one up here. Those are also equal. I just only need 2 pairs of angles to justify similarity. Then on the last problem over here, we actually have 3 pairs of angles that are equal to one another. This pair right here in the middle, if you recall, these right here are vertical angles. That's when two angles across from each other, or when two lines intersect, the angles across from each other are equal. And then again, we have this set of parallel lines here and here. And so I have these sets of parallel lines in a transversal, meaning that this angle and this angle are equal in measure because these are alternate interior angles, as are these two angles right here. These are also alternate interior angles based off of these parallel lines cut by this transversal and then this transversal as well. So we actually have 3 pairs of angles that are equal there. I only need 2 for similarity, so those two triangles are similar by angle similarity. Today's lesson is really going to continue our idea of determining similarity between two triangles. And so the directions on 3.2.5 says you now have a complete list of triangle similarity conditions, angle, angle, side, and side, 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 that can be used to verify the two triangles are similar. And so what we're going to do is just continue to build off of that. We talked about flow charts being a manner for us to be able to justify that two triangles are similar. We list our facts and then we write a conclusion. So in problem 94, this is a great practice problem. It says Lynn wants to show that the triangles at the right are similar. What similarities should Lynn use? And as we just look at this, hopefully you can recognize that we have, that was drawn very poorly. We have this side here and this side here that correspond with one another as the two longest sides. Then the shortest side would correspond with this short side of the triangle. And then we also have this angle in the middle of both triangles. And so this is a perfect candidate for us to be able to use side, angle, side similarity to justify that those two triangles are similar. But now what we need to do is just put that all into a flow chart, organizing our thoughts. So as a reminder, since I'm going to be using side, angle, side, I identified that's the condition I'm going to use to justify similarity. When I set up my flow chart for my proof, I'm going to need to draw 3 ovals. And these 3 ovals over here are going to represent the side, one set of sides, another set of sides, and the angle in between them that are the facts that I know representing similarity of these two triangles. So my first set of sides, the ones that I've highlighted in red, would be BA and KL. So what I'm going to say is that KL corresponds to BA, and that ratio is 6/3, which is 2. And so that would be the zoom factor or enlargement factor between those two sides. And actually I drew that, or I wrote that incorrectly. KL should correspond with AB, as this side length right here should be written AB in terms of the vertices corresponding with one another in correct order. So what I'm going to do is also list out the set of sides for the ones highlighted in blue that correspond with one another. So BC right here, this side length would correspond with LM. So I'm going to write in my oval that ratio of LM over BC, and that's equal to 16/8, which is 2. And so that is the same zoom factor, or the same enlargement factor as we got over here, which is exactly what we want. Because if these two sides are corresponding, we need both of these sets of sides to have the same zoom factor. I then know that in the middle of those two I have an angle that's the exact same. I know that the measure of angle B is equal in measure to angle L. And those would be my 3 facts in my flow chart. And using those facts, we can draw a conclusion then, and all of these arrows point to the conclusion. And this is where we write our similarity statement. This is where I'm going to write triangle BCA is similar to, using that little tilde. And it doesn't matter how you write the first triangle, BCA, but the second triangle has to correspond with its vertices. So B and L correspond with one another, so I need to start my second part of the similarity statement with L, and it's going to read LMK. So LMK, and down here I'm just going to write by side, angle, side, similarity. And so therefore, excuse me, that was drawn poorly. Those two triangles are similar, and that's how our flow chart would work. Moving on to problem number 95. Below it says, below are 6 triangles, none of which are drawn to scale. That's a key part to understand, that none of these triangles are drawn to scale with one another. Among the 6 triangles are 3 pairs of similar triangles. Identify the similar triangles and then make a flow chart. I'm not going to make a flow chart, nor am I going to ask you to do that for any of these. But what I do want to do is identify any of the similar pairs of triangles. So within this first triangle, I can conclude that this angle B is going to be 54 degrees by subtracting 90 and 36 from 180. And you should be able to recognize that, hey, I have this triangle ABC, and that has the same angles, or at least 2 of the same ones, as J and K down here is 90 and 54. So I know one pair of similar triangles is going to be triangle ABC, and that's going to be similar to triangle KJL, and that would be by angle similarity. I have 2 pairs of angles that are similar to one another. Looking at the second triangle up here on the top row, I see 110 degrees, and that corresponds with this 110 degrees here in the middle. This side length of 3 would correspond to this side length of 3, and then this side length 5 corresponds with this one. So there I have an angle with 2 sides on either side of it that are corresponding with one another with the same zoom factor, which would be 1. So then in my second set of triangles being similar with one another, I can say that, oh, I didn't include the triangle symbol in front of these other ones. I should do that. Triangle DEF up above is going to be similar to triangle. Now side length D corresponds with N, and M corresponds with E, and then F would correspond with P. So triangle DEF is similar to triangle NMP, and my reasoning for that one would be by side, angle, side similarity. And then the last set of triangles that we have here are obviously these last 2. I have an isosceles triangle, 2 side lengths that are the same. 3 and 3 correspond with 6 and 6. Obviously those are not drawn to scale, but the scale factor going from 6 to 3 is dividing by 2, and that's the same thing here. Going from 6 to 3, I'm divided by 2, so that's constant. And that same ratio is going to hold for the side length 4 and the side length 2. The zoom factor, or the scale factor between those side lengths is the exact same. And so I can say then, I can conclude that triangle GIH is going to be similar to triangle GIH would be RQS. So just noting that we can take a look at similar triangles, and this last set I didn't even write down, but that's going to be by side, side, side similarity. And hopefully you can notice that we use all three of our different sets of similarity conditions here. In problem number 96, not a whole lot to look at here. I'm only going to look at part A. It says, which pair of triangles are congruent, and how do you know? And if you look back to problem number 95, you should be able to notice that triangle, I think we said triangle DEF was similar to triangle NMP, and we said by side angle side. And there's something that we can actually conclude even more than that. These triangles are not necessarily just similar, but they are actually indeed congruent to one another. And when we write congruent triangles, we can put the little equal sign under the tilde. And the reason that I know that is because the scale factor, or the zoom factor between all the sides, was 1. And so therefore those two triangles would be congruent and not just similar. Congruence is more of a specific type of relationship, as that means they are the exact same, both same size and same shape. The last problem that we're going to do together today is looking at problem number 97, and I would encourage you to write this independently on your own. If you have not done so already, it says, are these triangles similar? If so, make a flowchart justifying their similarity. So I'm going to pause the video and let you try and do that, as this is an important skill that we've been developing over the last few days together, justifying similarity. So you need to take a look at which theorem I need to use, and then using that, which facts can I put together in order to come up with a correct assertion of which triangles are indeed similar to one another. Hopefully we arrived at this conclusion. The triangle RUN is similar to triangle CAT by side, angle, side. And I had to find two sets of sides that corresponded with one another, and that was RU and CA. And then RN and CT, they all corresponded with one another. The scale factor was 2, and I used side, angle, side because I didn't have another angle to be able to use in this bigger triangle up here. I only had one angle, so I couldn't use angle, angle. And I couldn't use side, side, side because I only had two sets of sides in this triangle. So I had to use side, angle, side as I had that relationship. And part B says, Charles has triangle CAT is similar to RUN as the conclusion of this flowchart. Lisa has NRU is similar to TCA as her conclusion. Who is correct? And what I want you to see is that, notice how Charles did CAT. C corresponds with R, as those are both listed first within the respective similarity statements, and A and U correspond, and T and N correspond. Let's see if those are all the corresponding ones that Lisa has also written. Here's N, and that has to correspond with T. Is that the same as up above? Yes, T and N correspond, as they're both written last in each of those triangle statements. R and C, well, yeah, those are listed first. And U and A are also corresponding, as that is how Charles listed them second. So they're actually both correct. It's just that Lisa listed this triangle first in NRU, and she wrote the corresponding triangle over here with TCA. They're both correct. It's just that they wrote them in a different order, but all of the corresponding angles are written together in the same order. So they're both correct. Now, are CAT and RUN congruent? I'm looking at letter C. Hopefully you can answer no, and the reason being is that the zoom factor between all the sides, or the set of corresponding sides, is 2, and it is not 1. So they are not congruent, they are similar. And it said find all the missing angles and side lengths of CAT and RUN. Well, if I wanted to do that, I should be able to determine that this angle right up here is going to be 180 degrees, subtracting 103 and 47, and that should leave 30 degrees. And in similar triangles, all of the corresponding angles are the same, so that means that this is 30, and this is 103 degrees. So therefore, I have all of the angles. And if I wanted to find the last side length, which would be this length right here, AT, I know that the scale factor to go from this triangle to this one is dividing by 2, and so taking 12.2 and dividing by 2, that gives me 6.1. So AT then has a length of 6.1. So we can use the similarity between the triangles to help us determine many of the other measurements within those triangles. So the last slide today is just looking at complete conditions for triangle similarity, and if you have not yet written this down in your notebook for math notes, I would include that. This is a phenomenal summary of what we've done. It says there's exactly 3 valid, non-redundant, redundant triangle similarity conditions that use sides and angles. And they're abbreviated side, 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 angle, angle, and side, angle, side. And this is an important piece here, in that in the side angle side portion, the A is placed between the two S's to indicate the angle must be between the two sides used. And that's why we're using side angle side a lot. But just as a reminder, we have 3 options to choose from to justify similarity. As we move forward through the rest of this week, we're going to be taking a test on Friday. And that's going to be Friday, and I believe that's going to be, trying to see what date that is, Friday the 17th. So you can count on that for this upcoming week. If you have any questions, by all means continue to stop by my office hours via Zoom. Hope you all stay safe and healthy. Talk to you soon. Bye.